Section 5.9 is about complex numbers. In the past, whenever we've had the square root of a negative, we've said that problems like that were no solution, undefined, because we couldn't do it. Now, we're going to learn about something called an imaginary unit that's going to allow us to deal with problems that have negatives underneath radical signs. An imaginary unit is represented by the letter I, and it's used when dealing with square roots that have negatives. So here we're going to call the square root of -1, we're going to call that I. It's not a variable, it's actually a number. It's an imaginary number called I. Well, if I square both sides of this, then I also get the fact that I squared is -1. These two ideas here will help us to simplify problems that have negatives in the radical. Here's an example. Square root of -18. In the past we've said that we can't do that. But now we can. We can break this up into square root of -1 times the square root of 18. Now, by definition, square root of -1 is now an I. So we put an imaginary unit there, and then we're going to take that separate. Now we'll simplify square root of 18. Well, I get square root of 9 times square root of 2. Square root of 9 is 3, so 3 root 2, and we're still multiplying by an I here. Now, when you write this, put the whole number first, then the I, and then the radical. So simplifying the square root of -18, I get 3i root 2. Next example, square root of -1, square root of 125, and square root of x to the 5th. Root -1 is an I. Square root of 125, well, I know that's root 25 times root 5, and the square root of 25 is 5. So that simplifies to 5 root 5. We still have an I here. And then over here, square root of x to the 4th. Remember, we make the exponents even, and then we cut it in half. So x squared. When you write the solution, we put the number first, and then we put the I, because I is an imaginary number. So it becomes before the variable, then the x squared, and then everything that's under the radical. The 5 is, and so is the x. And this is how you write the solution. Here are some examples where we'll use imaginary numbers. I'm going to multiply -2i and 7i, so we multiply -2 times 7, and then we multiply the I times I. Well, -2 times 7 is -14. And if you remember from the last slide, we were told that I squared equals -1. We're going to use that idea a lot on in this lesson here. So I times I is really I squared, and that's really a -1. So we have -14 times -1, and simplifies to just 14. Next example, square root of -1 times square root of 10, and that's times square root of -1 times square root of 15. Now you may already know that the square root of -1 is an I, and if you just want to pull those out right away, it's okay if you do that. So we multiply I times I, we'll get I squared, and I squared is really just a -1. So it's -1 times the square root of 150. Well, how does that simplify? We got to take out a perfect square of 25 times 6. And the square root of 25 is 5. And then we take the -1 that's out front times the 5, and we make it -5 times root 6. Last one is an I with an odd exponent. When you have that, just take it out, take a single one out, and make it to the even power. So now we have a single I times I to the 44th, and that's really an I squared to the 22nd power. And we know that I squared, again, is -1 to an even power is just a 1. So really when you have an I to any even power, you really just have a positive 1. Now it's still that positive 1 times I, so all of that simplifies to just be a single I. Here's an equation that previously we could not solve, but now we can because of imaginary numbers. I'm going to subtract 48 from both sides. 3x squared equals -48, and then divide both sides by 3. So x squared equals -16. Take the square root of both sides, so we'll get x equals positive or negative. Don't forget, when you introduce a square root, you have to bring the plus or minus. Now, before we would say that this is undefined. We can't take the square root of a negative. But now, because we have imaginary numbers, this is really just the square root of -1 times the square root of 16. which is I times the root 16. Now there's still a plus and minus there. And square root of 16 is just a 4. So this is really positive or negative 4i, and that's what x equals. Here's a key concept that explains what a complex number is. A complex number is simply when you have a number that's made up of a real part and an imaginary part. Something like 5 plus 2i is a complex number, because 5 is a real number, but 2i is an imaginary, and you either add or subtract them together. When you have something like this, it's called a complex number. In this example, we're asked to find x and y, but we aren't able to do that unless you understand that these are really just big complex numbers that we're looking at. This part here would be the real part because there's no I, but this part has an I, so this would be the imaginary part. Over here, the 3 would be the real part, and then the 2i would be the imaginary part. So because these two are equal, we can say that the real part, the 2x minus 3, must be equal to the real part over here, and we can solve that. We can also say that the imaginary part, y minus 4i, has to be equal to the imaginary part of 2y, and we can solve that also. Let's start over here by adding 3 to both sides. So 2x equals 6, and then divide by 2, x equals 3. And then this one over here, if y minus 4i equals 2i, then we say that y minus 4 must equal 2, and then we will add 4, and y will equal 6. Here we'll add and subtract some complex numbers. Since we're adding, we can treat this as if the parentheses really were not here at all. Now we can only add values that are real and then also values that are imaginary. So here I can add the 6 plus 1. It's like collecting like terms. And I can add negative 4i with positive 3i to get negative 1i. Typically you'd probably see that written this way, 7 minus I. Second one, though, is subtraction, so I can drop the first set of parentheses, but here I'm going to have to distribute. This is really a negative 1, so it becomes a minus 5 plus 4i. Again, we will combine the real part, so 3 minus 5 is negative 2, and then we will combine the imaginary part. Negative 2 plus 4 is positive 2i. Here we're going to look at complex conjugates. That's when you have two complex numbers, one with a plus, one with a minus, and we use this idea of conjugates to simplify. So here we're going to rationalize the denominator by multiplying by the conjugate 2 minus 4i over 2 minus 4i. We'll distribute the 3i, so 6i minus 12i squared, that's the numerator. The denominator, because it's a conjugate, we can follow the conjugate pattern, which is square the first number, so 2 squared is 4. Square the last, so that's going to be 16i squared, and then put a minus sign in the middle. Continuing further, I'm going to get a 6i minus 12. I squared is really a negative 1. So 6i plus 12 would be the numerator. And then the denominator, since I squared is a negative 1, this is really a 4 plus 16, because that's going to be a negative times a negative. So we'll get a 20 on the bottom. Now there's one more step of simplification I have to do, and that's I'm going to put the 12 first, and I'm going to put both of these over 20. And the reason I write it this way is because this is the real part and this is the imaginary part. So now we'll reduce. 4 goes into 12 3 times and into 25 times. So this reduces to a 3/5. Over here, 2 goes into 6 3 times and 2 goes into 20 10 times. So this is really 3 over 10i. And this is how you should write your solution as a complex number with the real and the imaginary. Same idea up here. This time, however, we don't need to use the conjugate idea to get rid of the I on the bottom. We can just multiply this by I over I. So we'll still distribute the I, 5i plus I squared over 2I squared. Now remember, each of these I squareds is a negative 1, so the top is 5i minus 1 over negative 2, because I squared is negative 1 times 2 gives you negative 2. We'll finish by making this the real and the imaginary part, so I'll put the negative 1 on the left, and then plus the 5i portion on the right. Both are over negative 2. So two negatives makes this a 1/2, and this becomes a minus because the negative goes out in front. 5/2 I. So the real part in the front, the imaginary part in the back.